Hello and welcome to section 3.7 I/O communication channels for the myRIO. This is a section from the real-time computing book that I wrote with Garbini and Devine. I'm Dr. Rico Piccone. MIT Press website has more info about the book, and the companion website is rtcbook.org. Check it out. Okay. The myRIO, which is the board we're using in this class, can communicate with target devices over several common communication channels: digital and analog, inputs and outputs, UARTs, SPIs, and I2Cs. All of these interface through three connectors, A, B, and C. With the exception of the UART lines, all are controlled through the FPGA. There is also a USB port and a wireless 802.11bgn interface for communication with the development computer, as well as audio input and output ports. The myRIO connectors. The A and B connectors, called MXP connectors by National Instruments, have identical pinouts shown in the figure. So A and B have the same pinout of 34 pins. Some pins have a primary and a secondary signal, which can be configured programmatically. So you see we have 1 being plus 5 volts, 2 being analog out 0, 3 being analog in 0, 4 being analog out 1, etc. There's the analog ground, digital ground. There's a bunch of digital input and output pins. And some of them have a primary and a secondary, like pin 18 has digital input output 11 on it, and it can also be used for the secondary purpose of encoder A as well. So we can do encoder counting. In addition to communication pins, there are power and ground lines. So plus 5 volts, plus 3 volts are two power lines, and then there are also the grounds that we already mentioned. Okay, so those are the A and B connectors at a glance. And the C connector, the MSP connector, as National Instruments calls it, has pinout shown in the figure. Some of these lines are somewhat different than those of the MXP connectors, so A and B are identical, but C is a little different. We will now consider lines by functional category in just a moment. You see the audio in and out. You see that we also have a plus 15 volts and a minus 15 volts on the C connector. We also have some more encoder pins and some more analog inputs and outputs. Power output. Strictly speaking, the power output lines are not for communication, but they're worth considering briefly. There is a 5 volt power supply line on each of the A, B, and C connectors. Each references the respective D ground line, i.e., it is 5 volts with respect to D ground. The specification guarantees that the output will be 5 plus or minus 0.25 volts with a maximum current draw of 100 milliamp per connector. The A and B connectors also have a similar digital ground reference, 3.3 plus or minus 0.3 volts output, with a maximum current draw of 150 milliamp. These power output lines are convenient for powering especially digital sensors and other low-power peripheral devices. The C connector has differential power output lines at plus and minus 15 volts with respect to the analog ground, A ground. The combined power these can supply is 500 milliwatts, so not very much. The differential supply is convenient for powering some analog sensors that require a differential supply. Resist the temptation to use the power lines for loads that exceed the power rating. They really can't supply very much power. Analog input and output. The analog input, AI, and analog output, AO, lines are present on all three connectors. The A and B connector, analog IO, AIO lines, are nominally 0 to 5 volts with respect to ground, A ground. The C connector has two differential analog inputs in the nominal range, negative 10 to positive 10 volts, and two analog outputs in the range, -10 to +10 volts. This is very convenient. Not a lot of boards have this. AIs and AOs are subject to processes called analog to digital conversion and digital to analog conversion, which will be discussed extensively in Chapter 6. Therefore, we will wait to consider other analog input-output specifications such as resolution, dynamic range, and bandwidth, which will be covered in that chapter. The primary use of analog inputs is the measurement of analog voltage signals, usually from sensors. Analog outputs can be used to control amplifiers that drive motors and other actuators, as we will see in Chapter 4 coming up. Digital input and output. There are multiple DIO pins on each connector, all of which have the reference D ground. Each can be programmed to be either an input, a digital input, or an output, a digital output. All outputs are of the 3.3 volt LVTTL logic family, which is generally compatible with 3.3 volt CMOS logic families, which is a very common logic family. All inputs are also of the 3.3 volt LVTTL logic family, but they are also compatible with a 5 volt logic level, which is also convenient. On connectors A and B, DIO lines 0 through 13 each has a 40 kilo ohm pull-up resistor to 3.3 volts, and lines 14 and 15 each has a 2.1 kilo ohm pull-up resistor to 3.3 volts. The C connector DIO lines each has a pull-down resistor of 40 kilo ohms to ground, D ground. When a DIO line is configured as an input, DI, it is in high Z mode and its voltage floats toward its pull resistor. For the A and B connector DI lines, the voltage floats toward the 3.3 volt level, so they're pull up resistors. For the C connector DI lines, the voltage floats toward ground, so we have a pull down resistor on each of those. This means when a DI is connected to an open circuit, i.e. it is disconnected, it will read high connectors A and B or low connector C. Some DIO lines have secondary uses. Some can be configured for UART, SPI, and I2C communication lines, as we discuss next. Others can be used for pulse width modulation, PWM, and encoder sensors, both of which are discussed in the next chapter. Okay, UART lines. The myRIO target computer has two configurable UART interfaces, one of which will be used in lab exercise 3 of this chapter to transmit data to the display. There is a UART on each of the MXP connectors A and B. The UART input pin on each connector is pin 10, and the output is pin 14. The output pins use the popular 3.3 volt TTL logic level, which is compatible with 3.3 volt CMOS. 3.3 volt LVTTL input pins are compatible with 5 volt logic levels. These specifications allow us to directly connect most peripheral devices that can receive 3.3 volt logic levels and those that transmit 3.3 or 5 volts. The input and output UART lines have 40 kilo ohm pull-up resistors to 3.3 volts. The UART lines have configurable baud rates of up to 230.4 kilobits per second. SPI and I2C line. The A and B connectors each have an SPI and an I2C bus with 3 pins for SPI and 2 for I2C. The SPI interface has only PISO, POSI, and clock pins, making it a 3-wire variant of a standard SPI that lacks the chip select pin for multiple peripheral control by the myRIO. The maximum frequency for the SPI is 4 MHz. The I2C interface is a standard 2-wire bus with data line I2C.SDA and clock I2C.SCL. Okay, so that summarizes the communication channels for the myRIO. We're going to use the UART extensively and the digital inputs extensively in the upcoming lab exercise. So looking forward to that. See you then.